Okay, good afternoon to all the students, and we are now into the 25th lecture of this series of Prerna scheme. Before this, we had 24 lectures already taken up on various topics. The topic what we'll be taking up today and the consequently three different lectures which are lined up are related to thermodynamics. Now, see, thermodynamics is a very vast subject, and this subject, as you know, is supposed to be the basic subject of thermal sciences. And there are various different topics which are related to thermodynamics, such as heat transfer, such as refrigeration and air conditioning, such as thermal sciences, such as uh, designing of thermal systems. So there are various topics which are related to engineering thermodynamics and thermodynamics, which is supposed to be a core subject of mechanical engineering. In this 1 hour session, we'll be basically dealing with the basics of thermodynamics. I'll be sharing my screen. So in this particular session, we'll be basically dealing with the core definition of thermodynamics and what is thermodynamics all about. Thermodynamics, as you can see, basically it is the branch of engineering science. It is a branch of engineering science which basically deals with the conversion of one form of energy to some another form of energy. Okay, along with the changes in the temperature incurred. So temperature, as you know, you must be knowing that temperature is basically a parameter which tells us the amount of heat which is stored inside any substance, or the amount of heat which is crossing a system boundary. We'll discuss all these concepts. So thermodynamics as such is a very vast field, but in thermodynamics, we'll be basically dealing with the conversion of one form of energy. So conversion of one form of energy. In this case, it is usually heat and work. So we'll be basically dealing with which type of energy? Heat and work, which would be converted to some another form of energy. And then this another form of energy, again, it could be heat, it could be work, it could be internal energy, it could be potential energy, it could be kinetic energy, it could be various forms of energy associated to heat and work, along with the changes in the temperature. Okay, so changes in temperature, the word changes in temperature is equally important. So for any thermodynamic activity, we are forced to believe that the temperature of the temperature of any substance or temperature of any medium is not going to remain constant. The temperature is bound to change. So for example, say if in Nagpur, say at 6 a.m. in the morning, the temperature is 18 degrees Celsius. So 4 hours, 30 minutes down the line, say at 10:30 a.m., again the same place, Nagpur, the temperature could be 28 degrees Celsius, right? So in a span of 24 hours, the temperature of any place, any region, or any space is changing continuously, which means that temperature is not constant. Temperature is not constant, or we can say that is changing. So temperature is changing. Now, when we say temperature is changing or temperature is not constant, then comes the concept of thermo, which is also called as temperature, and dynamics, which means changing. So we'll say whenever the temperature of any body or the temperature of any substance or the temperature of any object or the temperature of any system, to be very specific, is changing. Changing refers to the word called as dynamics. So whenever we come to know that the temperature of any system or the temperature of any object or the temperature of any body or a temperature of any particle, or in a very broader spectrum, the temperature of any mass. So the temperature of any mass or matter, if it keeps on changing, and it will in the due course of time, as time changes, the temperature of any system will keep on changing. The temperature of any matter will keep on changing. So we say we are into the world of thermo means temperature, and dynamic means changing continuously. Dynamic means changing continuously. Okay. So I hope you must have now understood what do we mean by thermodynamics. So as such, different books and different authors and different people in the field of engineering science can have different concepts of thermodynamics, but according to me and according to various books also, the branch of engineering science, so this is equally important, the branch of engineering science which deals with the conversion of one form of energy. In thermodynamics, this form of energy is usually heat, it is usually work. So this conversion of heat, conversion of heat and work into some different, another or different form of energy. So I'll write to some different or another form of energy associated with, along with the changes in temperature incurred. This is the basic definition of thermodynamics. So in order to understand what thermodynamics is, and in order to understand how do we basically go through this particular topic, we have bifurcated the whole syllabus, say, or into two different domains. The first one, as you can see, thermo, which means temperature, dynamics means changing continuously. Now, thermodynamics will not exist. This is an equally important statement. For example, thermodynamics will tend to leave, or thermodynamics will be finished, if the temperatures of all the bodies in the universe is set constant. इन अदर वर्ड्स, अगर हम ये बोलते हैं कि पूरी बॉडीज या पूरे ऑब्जेक्ट्स या पूरा मैटर जो है उसका टेम्परेचर जो है कोई एक फिक्स वैल्यू पे आपने रख दिया, सो द टेम्परेचर ऑफ एनी बॉडी, एनी मैटर, एनी मास, if it is constant or if it is not changing, say at some fixed value, so I have say suitably taken 25 degrees Celsius. So if the temperature of any substance, the temperature of any body, the temperature of any medium, the temperature of any particle, the temperature of any matter is set constant at some fixed value, say it is 25 degrees Celsius, then we will say, and that 25 degrees Celsius will not change. So this T equal to 25 degrees Celsius will not change with time. Even though the time will change, the temperature, say 25 degrees Celsius, is not going to change. If such condition arises, if such condition is practically possible, then we can say that thermodynamic will not exist, or thermodynamic will be out of question. So in order to support my argument, what will I say? That say tea or chai, or as it is popularly known in India, say tea is at 25 degrees Celsius. So tea, the maximum temperature of tea, say, is 25 degrees Celsius, and the minimum temperature of tea is also 25 degrees Celsius. Similarly, ice cream. So ice cream is also there, but it is at 25 degrees Celsius. Now it's not possible. How can you think that ice cream will be at a temperature of 25 degrees Celsius? Steam, which is a form of steam, which is basically a form, or I can say vapor phase of water, say is at 25 degrees Celsius. That is each and every body in the universe, be it Earth, be it some other planet which is close to Earth, or any planet of our solar system, say Jupiter or Venus or Mercury or Saturn, or for that matter, all the planets in the solar system, including the sun itself, the temperature is set at 25 degrees Celsius. Steam, which is basically what? So, what is steam? Steam is basically the vapor phase of water. Say that's we know that water boils at 100 degrees Celsius. Before 100 degrees Celsius, water will be in the liquid phase. But then if we are forced to believe that the temperature of steam is also at 25 degrees Celsius, then we can come to a conclusion, we can arrive at a conclusion which basically tells us that each and every body, each and every substance, each and every matter, the temperature is set at 25 degrees Celsius. And that temperature is not going to change. So whether it is steam, whether it is tea, whether it is coffee, whether it is ice cream, or whether it is ice for that matter, each and every body, each and every substance, each and every matter is set at a temperature of 25 degrees Celsius. Now I've chosen 25 degrees Celsius. We can have any other suitable constant value. So if such happens, then I'll say that thermodynamics will not exist. But practically speaking, such kind of things, even imagining such kind of things is not possible. So if we are in India, so the temperatures in India ranges from um, at some places it could be 40-45 degrees Celsius. At some places it could be -5 or -6 degrees Celsius if we go move north. So over a span of time, in a particular place, in a particular region, in a particular location, the value of temperature is not constant. So temperature continuously goes on changing day in, day out, various months of the year and various days of a month and various hours of a day. So temperature keeps on changing. And the moment we are forced to believe that the temperature of any substance or the temperature of any body or temperature of any matter or mass is not constant and the temperature is changing, we are into the domain of thermodynamics. So what I was discussing about in the last 5 to 10 minutes, I was trying to explain the importance of this particular subject and the consequences of these subjects in various allied engineering branches. Okay. So we move further now, and as we know that the temperature is not going to remain constant and the temperature will change. Now, in order to understand any particular thermodynamic activity, if you want to understand any particular thermodynamic activity, so what we know that any particular thermodynamic system, we will basically try to know what is a thermodynamic system. So as you can see in this particular diagram, this is a enclosure, and every thermodynamic system should have a boundary. So there is a system boundary. So what is a system boundary? It is a definite enclosure. There has to be a definite enclosure or a definite barrier or a definite boundary which is going to separate what? Separate the system from the surrounding. So I'll just add something. So we have a system boundary, and we also have a surrounding. We also have a So this is the surrounding. Now what is basically a surrounding? In order to know what is surrounding, we should initially basically know what is a system. Okay, right? What is a system? So as you can see in the definition, basically any definite enclosure, so this is we have a definite enclosure. Okay, so any definite enclosure or particular space or particular region, etc., etc., which is under any thermodynamic consideration. Thermodynamic consideration means the temperature is changing. So I'll add over here thermodynamic consideration, that is temperature is changing, or where any particular thermodynamic activity is going on. Such type of place, such type of enclosure, such type of region is what is called as a thermodynamic system. So what do we come to know by this particular statement is that any particular, any definite, so there should be certain definitiveness in that space. It should not be open, it should be identified, it should be, it should be traced, it should be, it should have a some kind of boundary. Okay, it should have some kind of boundary. Now what this boundary does, this boundary basically it is a definite enclosure. Okay, it is a definite enclosure. So what does this enclosure do? So what is the system boundary? It is a definite enclosure. Okay, and what it is doing, it is separating the system from the surrounding. So what is the surrounding? Everything outside the system, everything outside the system is what is called as the, it is called as the surrounding. Everything which is outside the system is called as the surrounding. So we have a definite enclosure. So this is a definite enclosure. This definite enclosure is called as a system, called as thermodynamic system. Inside this particular enclosure, inside this particular space, inside this particular region, some kind of thermodynamic consideration or some kind of temperature changing activity is going on. Some kind of temperature changing activity is going on. And this specific region, this specific location, this specific enclosure is separated from the surrounding with the help of the system boundary. So if you consider a cricket match which is going on, so in that cricket match we have a specific boundary. So there are 11 plus 2, 13 players on the ground along with the umpires who are on the ground. So all those players who are playing on the ground are part and parcel of that system. And everything which is outside the ground is supposed to be the surrounding. Likewise, each and every game has a definite boundary region. The football has a definite earmark region inside which a particular sport is going on. So in the same fashion, if we consider, if we consider that we have a particular region, we have a particular space, we have a definite enclosure where any specific thermodynamic activity or temperature changing activity is going on, that particular place, that particular region, that particular space is what is called as thermodynamic system. Okay, I'll just check if anyone is having any questions, any queries. Okay, so we have Sujan, Abhik, and other students who have already joined the lecture. Okay, anyway. So, I hope you must have understood what is a thermodynamic system. Now, this every thermodynamic system is always enclosed by a boundary. Okay, so as you can see what I have written over there, every thermodynamic system is always enclosed by a boundary. Okay, this boundary is called as the system boundary, called as the system boundary. This boundary, thermodynamic system boundary, is called as the system boundary. Okay. Now, everything which is inside the system, जो कुछ भी उस thermodynamic system के अंदर है, it is a part of the system. Okay, it is a part of the system. Everything which is inside the system. So if this blue color rectangle, what you can see, so if this is the thermodynamic system, so each and every mass or each and every element which is inside the thermodynamic system, okay, is a part of the system, whereas everything which is outside the system, जो कुछ भी सिस्टम के बाहर में है, जो उस सिस्टम के अंदर नहीं है, that is what is called as the surrounding. So we have a system boundary, और उस सिस्टम के अंदर में there is some thermodynamic activity going on, and this thermodynamic activity is going on in a particular definite region, it is going on in a particular definite place, it is going on in a definite particular enclosure. This enclosure is called as a thermodynamic system, and every thermodynamic system necessarily should have a system boundary. So basically the boundary is the demarcation between the system and the surrounding. The boundary or the system boundary, so as you can see over here, the system boundary always separates the system with its surrounding. So when we talk of thermodynamics, the first thing what we need to discuss about, and the first thing what we need to understand, is the concept of system and surrounding. So if we know that there is a specific thermodynamic system, and this specific thermodynamic system is a definite region, so I'll just add over here, it is a definite region, space, okay, or enclosure. It is a definite region, space, or enclosure where any thermodynamic or temperature, or inside this inside this blue color rectangle, which we are calling it as a system, the temperature is changing. Okay, and every system is bounded by a system boundary. There has to be a system boundary. So there is a particular system boundary which is the enclosure to the system, and everything which is outside the system is called as surrounding. Okay, now we move one step further, and we will now try to understand what are the various types of system. Okay, what are the various types of system? So in thermodynamics, see, basically there are three types of system. The first one is called as the open system, the second one is called as the closed system, and the third one is called as the isolated system. There is no fourth such another system. Okay, so there is only three systems what we can have. So we can have three different types of system in thermodynamics. The first one, the open system, the second one is called as the closed system, and the third one is called as the isolated system. Now what is an open system? So as you can see from the text matter, an open system, it is a system which allows what? Allows the transfer of mass, right, and energy, allows the transfer of mass and energy from entering and leaving the system. It also means that mass and energy can cross the boundary of the system. The energy what we are basically interested in this case is heat and work. Okay, so a system which will allow the transfer of mass. So mass can come inside from the surrounding into the system. Mass can leave the system and go into the surrounding. So there is no constraint on the transfer of mass from coming inside and going outside the system. Similarly, there is no constraint on the energy factor. Heat can come inside the system, heat can leave the system. Similarly, work which is also a type of energy, which is our basic point of interest in thermodynamics. So heat and work are two different types of energy, which we will be extensively talking about. So heat and work, both these energies can come inside the system, can leave the system. There is no constraint in the energy entry and the energy exit. The both mass and energy can cross the boundary of the system. So when both mass and energy can cross the boundary of the system, such type of system is called as a open system. Such type of system is called as a open system. So this was the basically the diagram what I intended to show. So an open system is a system which allows the transfer of mass and energy from entering and leaving the system, right? So if I put over here, okay, so I'll say mass. So this is energy which is entering, okay. So energy is entering, and say energy is also leaving. Just change it. Fine. So energy, as you can see, in the form of heat and work. Energy in the form of heat and work. Okay, so this energy is entering, and at the same time, the energy can now leave the system also. So energy in the form of heat and work is entering the system, and energy in the form of heat and work is can leave the system also. Similarly, we can take mass. So I'll say I have some mass over here. Okay. I'll put number 1. So we have mass which is entering the system. Okay, so mass is entering the system. Fine. And at the same time, mass can also leave the system. Mass can also leave the system. So the mass is now leaving the system. Okay. So mass can also leave the system. So this particular system is allowing the entry of mass. This particular system is also allowing the mass to leave from the system. At the same time, it is also allowing energy in the form of heat and work to enter the system. It is also allowing energy in the form of heat and work to leave the system. So a system which allows both mass along with the energy to enter at the same time to leave the system, such type of system is what is called as a open system, and this is the system boundary. This is the system boundary. So the red color area, what you can see, this red color region is what is called as the system boundary. So in this particular diagram, we are basically trying to understand that mass can cross this red color boundary and come inside. At the same time, mass can cross this red color system boundary and go outside. At the same time, simultaneously, energy in the form of heat and work can cross the boundary and come inside. Energy in the form of heat and work can cross the boundary and come out of the system and go to the surrounding. Okay. So this is basically a very raw kind of example for understanding what is a open system. Examples of open system include water which is boiling in an open container. So if you take a container, you fill water in it, and then you heat that container. Okay. So initially, if you take water in a container, it would be at around say 20-21 degrees Celsius, and then you want to heat that water, you need to increase the temperature of that water. So in order to increase the temperature of water, what we want to do, we will have to supply heat. Unless and until you supply heat, the temperature of water is not going to increase. So you started heating the water, okay, and the temperature of water gradually increases from 21 degrees Celsius to 25 and then 30, and then you go on supplying heat to the system, the temperature further increases to 60, 70, and then it reaches to 90 degrees Celsius. And then finally, when you reach up to 99, and now the temperature is 100 degrees Celsius. So the moment temperature reaches 100 degrees Celsius at atmospheric pressure, which is 100 degrees Celsius, which is the boiling point of water at atmospheric pressures. The boiling point of water changes according to the pressure. So the moment temperature reaches to 100 degrees Celsius, the water which is inside the container will start boiling. The moment water starts boiling, so you will be having bubble formation on the surface of the water in the container, and that those bubbles will just break up, and steam in the form vapor, steam vapor will then leave the surface and it will go into the atmosphere. So if you are taking an open container and water is boiling in an open container, water in the form of steam and hence mass is now leaving the system. So we have a condition where water in the form of mass is now leaving the system, and this mass or this water which is leaving the system can be considered as an open system. Okay, so in this case mass is now leaving the system. Fine. But at the same time, since you are supplying heat, so heat energy, energy in the form of heat is also entering the system. So when you are boiling water in an open container, it is an example of a open system. So I hope by now you must have understood what is a open system. So if you take any container, if you find any particular region, any definite enclosure, any definite space, which though has a system boundary, but that system boundary is open to the surrounding, it is open to the atmosphere, which allows the transfer, as I have already written over here, it allows the transfer of mass, it allows the transfer of energy. From transfer of energy crossing the system boundary, energy can come inside, energy can go outside, mass can come inside, mass can go outside. So if we are able to do so, if you are able to if the system is able to interact with the surroundings, and this interaction is in the form of mass, it is in the form of heat, work, energy, then such type of system is called as an open system. Okay, if anyone is having any doubts, if anyone is having any queries, they can post the comment in the comment box, so that if you are having any doubts, or if you are having any difficulties, I can definitely uh, help you out. Okay, anyway, so now we move on to the next type of system, which is called as the closed system. What you can see over here is an example of a closed system. Now what happens is, in a closed system is a system which allows, so what does it do? It allows only the transfer of energy, right? Energy can enter the system, energy can leave the system. So only energy in the form of heat and work, energy in the form of heat and work. It will enter the system, it will leave the system. It does not allow the transfer of mass. It does not allow the transfer of mass from crossing the boundary of the system. That is, the total mass contained of the system remains constant. So mass cannot leave, mass cannot enter, right? You cannot have a condition where, what I'll do is, just a minute. So this is the closed system. Fine. What we'll do is, we'll think of So I'll say this represents energy. What is this? Energy. Okay. Energy in which form? Energy in the form of heat and work. So as you can see, energy is entering the system. Energy is entering the system. In which form? Energy in the form of heat and work is entering the system. And at the same time, the same energy is also leaving the system. So this energy in the form of heat and work is now leaving the system. So energy comes inside, it crosses the boundary, and at the same time it is now leaving the system. Okay. But what about mass? What about mass? Mass is not allowed. Mass is not allowed. Mass is not allowed to enter the system. Mass is not allowed to leave the system. This is the system boundary. Okay. Okay. There's some problem with this. Anyway. So this is the system boundary. I'll just show it over here. This is the boundary. This is system boundary. And system boundary, the red color dot, what you can see, red color rectangle, what you can see is the system boundary. So the energy in the form of heat and work is coming inside the system. Energy in the form of heat and work is crossing the system boundary. But mass is not allowed to do so. Mass cannot cross. Mass cannot leave the system. Okay. Fine. That will do. So this the mass cannot come inside. Okay. Mass, it is not able to go inside the system. So the mass which is outside is not allowed to enter the closed system. Similarly, mass which is inside, amount of mass which is inside the system, okay, it is not allowed to leave the system. So when you are putting restrictions, when you are putting restrictions on what? Restrictions on what? Restrictions on the transfer of mass from surrounding into the closed system. Restriction on what? On the transfer of mass from the closed system to the surrounding. So you cannot have a closed system wherein mass will come inside the system or mass will leave the system. No, not allowed. In a closed system, you cannot, the system cannot transfer it. There can be no mass interactions with the surrounding. The system cannot have mass interactions with the surrounding in case of a closed system. In case of a closed system, we cannot have a scenario where the mass will come inside the system from the surrounding. In case of a closed system, we cannot have a scenario where mass will leave the system and go into the surrounding. The only thing which is allowed is the transfer of heat or the transfer of energy. तो मास अंदर नहीं आ सकता, मास बाहर नहीं जा सकता. एनर्जी अंदर आ सकती है हीट और वर्क के फॉर्म में, and energy can also leave the system. So a system which allows partial entry and exit, a system which allows partial entry and partial exit, a system which allows only the transfer of energy, only the transfer of energy in the form of heat and work from entering and leaving the system. It does not allow the transfer of mass from, this word is important, crossing the boundary. Does not allow mass to cross the boundary of the system. And when the mass cannot come inside, mass cannot leave the system, it means what? The total mass content. The total mass content of the system will always remain constant. It will not change. So, I hope you must all have understood what is a closed system. What was an open system? In an open system, there is no restriction. The diagram what you can see now is that of an open system. So in an open system, there is no restriction on the entry and exit of mass and energy. No restriction on what? On the entry and exit of mass and energy. Whereas in case of a closed system, there is restriction. There is restriction on the entry of mass. There is restriction on the exit of mass. Only energy can cross the system boundary. So the example over here is hot tea. One of the examples is what? Hot tea. So this hot tea is enclosed. Where it is enclosed? Inside the thermos flask. Okay, it is enclosed inside the thermos flask. So if you take hot tea or hot coffee or anything, say hot water, and you put it inside the thermos flask, so this hot tea, only heat is allowed to leave. Now there can be certain cases where if you take hot tea and keep it in a bottle, so heat in any case will leave the bottle. So after some period of time, say 1 hour or 2 hour, the tea will no longer remain hot. It will cool down. The same thing if you use a thermos flask. So in a thermos flask, you have put tea, say at 70 or 80 degrees Celsius. Now it's not going to remain 70 and 80 degrees Celsius for 2 days, 3 days, 1 year. One day or the other, one time or the other, the temperature will reduce. So if the temperature is reducing, it means what? If the temperature is reducing, it means that heat is leaving the system. Heat is leaving the system. But the quantity of mass of tea inside the system will always remain same unless and until extra additional tea is added, or unless and until tea is taken out from the thermos flask. So thermos flask then becomes an example of a closed system. It allows only the transfer of energy in the form of heat from the system into the surrounding. So this was all about the closed system, which allows the transfer of energy only. It does not allow the transfer of mass. Now we move on to the third type of system, which is called as the isolated system. Now, what is an isolated system? Isolated system is simply no one can come inside, no one can go outside. No one means neither mass nor energy. Neither mass is allowed to enter. So, what we are saying, an isolated system is a system which does not allow the transfer of mass, as well as it does not allow the transfer of energy from entering and leaving the system. That means what? The total mass and total energy content of the system will always remain constant. Practically, such type of system does not exist in actual practice. So we have a special kind of system over here called as isolated system. Now in an isolated system, what we have, see, this is mass. A mass cannot enter, as it was in the case of a closed system. तो mass अंदर नहीं आ पा रहा है, and at the same time mass बाहर भी नहीं जा सकता है. So it was in case of a closed system. Closed system में the mass entry exit was not allowed. Along with mass, now energy can also not come inside. No energy can come inside. Energy is not allowed to go inside. Energy in the form of heat and work. So energy in the form of heat and work, it's not allowed to go It's not allowed to enter the system. Energy is not allowed to, energy in the form of heat and work is not allowed to enter the system. I'll just change the arrow. Just a minute. So see, energy is not allowed to enter the system. Fine. As in case of a closed system, energy was allowed to enter the system, and at the same time, energy cannot leave the system. Energy cannot. This is energy. See, energy in the form of heat and work. Energy in the form of heat and work cannot leave the system. So in an isolated system, no one can go anywhere. Heat which is outside the system will remain outside. Work which is outside the system will remain outside. That heat, that work which is in the surrounding, which is not a part of system, is not allowed to enter. Similarly, the energy which is inside the system, energy in the form of heat and work, okay? Energy in the form of heat and work, it's not allowed to leave the system. So the energy which is outside will remain outside in the form of heat and work. Energy which is inside will remain inside in the form of heat and work. So energy is not allowed to go anywhere. So if energy is not coming into the system, energy is not leaving the system, so what we can say? We can say that the total energy content in the form of heat and work is constant. The total energy content in the form of heat and work is constant inside the system. At the same time, mass is not allowed to enter, mass is not allowed to leave. So the total mass content of the system also remains constant. So an isolated system is basically a system wherein neither mass, neither energy can cross the system boundary, and hence the mass which is inside the system remains constant. The energy which is inside the system remains constant. And as we can already understand that practically such type of system does not exist in actual practice. Why? Because even though we can consider the universe can be considered, it could be considered to be an isolated system. Now, why do we consider universe to be an isolated system? We do not have any, as such, we do not have any proven theory that some kind of energy is coming inside the universe. The universe is a huge entity. So as of now, we don't know whether some energy is coming inside the universe or some energy is leaving the universe and going outside. Or we don't know whether some mass is coming outside from the surrounding into the universe, or for that matter, some mass is leaving the universe. So as such, there is no proven theory which states that energy is entering the universe or energy is leaving the universe, or mass is entering the universe or mass is leaving the universe. So we can assume that universe can be considered to be a isolated system, right? So an isolated system, I'll just repeat, it is basically a system which does not allow, which does not emphasize, which does not contribute in the transfer of mass and energy. We can also say that isolated system has no contribution, right, in the transfer of mass and energy. There is no contribution in the transfer of mass and energy. So an isolated system is a specific kind of system which has no contribution, zero contribution for what? For transfer of mass and energy. unlike in the case of a closed system. So in case of closed system, even though mass was not allowed to enter the system, even though mass was not allowed to leave the system, energy though was able to enter the system in the form of heat and work. Energy though was able to leave the system in the form of heat and work. So energy had the capacity to cross the system boundary. As in case of a open system, as in case of a open system, as you can see the diagram of the open system. So in case of open system also, energy was able to enter the system, mass was able to enter the system, energy was able to leave the system, right? Mass was able to leave the system. Mass was, both mass and energy were allowed to enter and exit from the system, which was an example. This is the diagram of an open system. So basically all thermodynamic systems are broadly classified, though they are classified into three categories: open system, closed system, and so this one, the diagram what you can see is the open system. Energy can enter, energy can leave, mass can enter, mass can leave. The second type of system is the closed system. Only energy can come in, only energy can go out. Mass cannot come inside, mass cannot go outside. So the total mass content is constant. And finally, the third type of system, wherein no type of energy can come inside, no type of energy can leave the system, neither can mass enter the system, neither can mass leave the system. So this is a isolated system. The third one is a isolated system. I already suggested, I already told you that such type of system, which type of system? The isolated system. Practically such type of system does not exist. You cannot create an isolated system. You cannot think of creating an isolated system in this world. We cannot have an isolated system, because when you talk of isolated system, the theory is very simple. For example, if you close the door of your room, if you close the window of your room, as all the doors and windows are closed, and in the month of May, when the temperature in Nagpur, say, is at around 45 or 46 degrees Celsius, even though the doors are closed, even though the windows are closed, even though each and every boundary of your house is closed, in that case also, heat on its own will find its way and come inside your house. Your house will get hotter and hotter. So we cannot think of why, because why heat is coming? Because there is a temperature difference. There is a temperature difference in what? The outside temperature. Difference in what? The inside temperature. So the outside temperature in May could be around 45 46 degrees Celsius. The inside temperature, in the temperature inside the room, could be around, say, 30 degrees Celsius, 30 to 32 degrees Celsius. There is a temperature difference. And since there is a temperature difference, we are studying this subject, engineering thermodynamics. Thermo stands for temperature. Dynamics means changing. So the temperature is bound to change over a period of time, over a period of days, over a period of hours, months, years. A temperature of any system will change. And if the temperature changes, because you cannot stop, you cannot, human beings do not have the capacity and capability to control the atmospheric temperature. You cannot change the way the nature has been progressing through. So since temperature cannot be constant, since temperature is not constant practically speaking, and temperature is not allowed to change, temperature is allowed to change, temperature will change in the due course of time. So if there are changes in temperature, heat energy will find its way. Heat energy, or energy in the form of heat, will find its way out. Heat always flows from a high temperature body to a low temperature body on its own. We'll be discussing these concepts in the next few lectures. So we practically say that isolated system is practically not possible. As such, isolated system is practically not possible. We cannot have a particular region, we cannot have a particular space. Even if we think of that, a particular region or a particular space where temperature is changing, we'll always come across regions, we'll always come across places where temperature is changing. And if temperature is changing, then heat, you cannot stop heat from entering into a particular location. You cannot stop heat from leaving from a particular location, because flow of heat is directly related to the temperature difference. The transfer of heat is directly related to the temperature difference. The moment there is any temperature difference, heat on its own will find its way to flow. Heat on its own will find its own way to reach a particular space, because heat flows due to temperature difference. We cannot think of a particular region or space where you can stop the flow of heat from leaving the system, or you can stop the flow of heat from entering the system. Hence, the first two types of system, the open system and the closed system, both are practically possible. You can have an open system, you can have a closed system, because in both, in open system as well as in closed system, in both these diagrams, energy is entering and energy is leaving. In an open system also, energy is entering the system, energy is leaving the system. In a closed system also, energy is entering the system, energy is leaving the system. It is only in the case of isolated system where we do not want the energy to enter, we do not want the energy to leave, and this is practically impossible. Because since temperature changes are taking place across the globe, across the world, across the surroundings, since temperature differences are taking place, energy will come into the system, energy will leave the system in the form of heat. Hence, practically, isolated system is not possible. Fine. So this whole session for today was basically dealing with thermodynamics. What is thermodynamics? It is the branch of engineering science which basically deals with the conversion of one form of energy, usually heat and work, to some different form of energy, along with changes in temperature. So temperature is changing is a universal phenomena. It is a global phenomena. Temperature will change, and we talked about what is a thermodynamic system, what is a system boundary, what is a surrounding, and then we also talked about the various three types of systems. So we can have three different types of system: open system, closed system, and isolated system. And practically, isolated system is not possible. So that was for today's lecture. In the next session, we'll be dealing with some more different kind of thermodynamic concepts. We'll be dealing with different kinds of thermodynamic properties. We'll be basically understanding what are the various states of a system, what are the processes, what various combinations, permutations and combinations can take place when any thermodynamic activity is going on, how is pressure related to temperature, what is the effect of changes in temperature, changes in pressure, changes in volume, and all those things. So thank you very much. This was I am Professor Sajid Siddiqui, and I'll be logging out now, and we'll be again continuing with another fruitful lecture on the topic engineering thermodynamics. Thank you very much. Thank you one and all.